All right, guys. What we're doing today is continuing on with our systems of linear equations with three variables. Systems of linear equations with three variables. And whenever we start solving any of these here, the first thing we want to do is pick a variable to eliminate first and eliminate our equation. Now, looking at this one here, really x, y, and z are all good choices. And the reason I say that is if I look at the original equation, the number in front of x, the top one, is 1. The number in front of y is 1, and the number in front of z is 1. So with this first equation, we can turn it into either of the other two easily. And that's really what we're looking for. So I'll let y'all pick. Which one are we going to eliminate first? X, y, or z? We'll do y first, because that's what we picked. So we're going to eliminate y first. Now, the eliminator equation that we use really is just going to be which one we're going to use to eliminate y from the other two. Now, in this case, there's actually two we can use. We could either use the top equation or the bottom, because in both cases, the value in front of y is 1. So it's easy to use. I'm just going to use the top equation as our eliminator equation. We just have to pick one. And now that we have it picked, we can write the other two. Here. So we're on example problem number 2, top of the second page. Now the first thing we want to do is to get the y values to be the same with the one on the right. So the one on the right, the value in front of y is 5. So what do we need to multiply by our y to get it to be 5y? 5. So we're going to multiply the whole equation by 5. So we have, let's make sure both sides, x plus z. So we're going to distribute the 5. 5 times x is going to be 5x. 5 times y is 5y. And 5 times z is going to be plus 5z is equal to 10. And again, just like yesterday, we'll put it right underneath that equation. Questions on this here so far? Okay. No questions until we got to this spot. So looking at this here, we want to eliminate the y's. We want that to become 0. So would we add the two together or subtract them? So we can subtraction first. 5y minus 5y. 5 minus 5 is that what we wanted? Yes. Okay. So that means we're going to subtract all the way across. So the first one, 5x minus 5x is 0. Okay. So they're gone. 5y minus 5y is 0. 5z minus 5z is 0. Yeah. So now the whole thing becomes 0, so we actually have to put it in. If one of them cancels out and becomes 0, but we do have y or z or just z, we just put in the z's value. We don't have to put in 0x plus 0y plus 0z, because that just all equates to 0. Now let's look at the other side. 3 minus 10 is? Is that a true statement? So this here is we're done. It doesn't matter if the other two planes intersect or cross each other, because as we just saw with these two here, these two planes are parallel to each other. They'll never cross. And again, for us to have a solution, we need all three to intersect, all three to cross. And if two of them do not cross or intersect, it's no solution. It doesn't matter what the other one does. Okay. Any questions on the previous one before we move on to this one? Okay. This one's easy too. It does have a nice setup. Because which variable do we want to eliminate first? Because x would work because we do have x, x, and 5x, yes? So we can change one to the other. The middle one we have y, y, and 5y. And what do we have with z? Z, z, and it's 1, 1, 1. So we can do x, and there's nothing wrong with doing x. Z is the easiest because are the numbers in front of z already all the same? So we can just use it. Now the key question, or the next question is, which equation do I want to use to eliminate from the other two? Okay. The top one or the bottom one? Yeah. It doesn't matter because since they all three have the same value, we just need to pick one to eliminate from the other two. Normally we pick the smaller one and use it. So even with x and y, I could pick from the top two. I just have to pick one. Now, let's not do this in a crayon. And I'm going to write the other two back out. X minus y minus z is equal to negative 3. 5x minus 5y plus z equals negative 15. Since I don't have to do anything to z to get the numbers in front of them to be the same, we can just put them underneath. Kind of like yesterday when we got down to our two equations with two variables. Since the values in front of y were the same, we just put them on top of each other and simplified. Questions on this here? Let's look at the one on the left first. Since we're wanting to eliminate z, will we add or subtract? Subtract. Negative z minus z. Negative 1 minus 1 is? Negative 1 minus 1 is? So let's try addition. Negative 1 plus 1 is?
0.
So in this case, we need to add. If the signs are the same, we subtract. If the signs are opposite, we add. If the signs are the same, we subtract. If the signs are opposite, we add them together. So here, we're actually going to be adding. On the other side, we'll get there here in a second. Let's do this one first. X plus x is?
2x.
Negative y plus negative y is? Negative 3 plus negative 3 is? Negative 6, and I ended up skipping over it. But our negative z plus z is indeed 0. Questions on how we got the equation on the left-hand side? Let's look at the right-hand side. So to eliminate z, would we add or subtract? Z minus z. Is that 0? Yeah. And again, are the signs in front of z the same? It's plus and plus, so we would subtract. If it was minus and minus, we would still subtract. If it's positive and negative, one's positive, one's negative, then we add. If the signs are opposite, we add. If the signs are the same, we subtract. And we can subtract these here. 5x minus x is? negative 5y minus negative y? Well, the minus and the second negative make a plus. So negative 5y plus y is negative 4y. Z minus z is 0, just like we wanted. Negative 15 minus negative 3. Negative 12. Yeah. It is very tempting to say 18, because if we were adding negative 15 and negative 3, then it would be negative 18. But because the subtraction in that second negative, it switches it the other way. But again, with any of these adding or subtracting them from each other, plug them in a calculator. Let it do it for you. Because we could plug it into the 30XS, the little yellow calculators, and say negative 15 minus negative 3. Hit enter. It'll tell us it. It does not mind doing the double negatives. Questions on this here? Okay. Now we need to eliminate a second variable. Do we want to eliminate x or y? Doesn't matter. Because what do I need to multiply 2x by to get 4x? What would I need to multiply by 2y to get 4y? 2. They're both 2, but they're also both easy to do. It's not going to be where I have to multiply both equations by a number. So I'm going to rewrite our 4x minus 4y equals negative 12. I do this because, one, so really the main reason, it's not going to change. I just need to change the other one. Because I need to change the 2x minus 2y equals negative 6. And what do we need to multiply the 2x by to get 4x? 2. So we're going to multiply the whole equation by distribute.
Addison Jones, please come to the office. Addison Jones, please come to the office.
So when I distribute the 2, 2 times 2x is 4x. 2 times negative 2y is negative 4y. And 2 times negative 6 is negative 12. Last part, do we add or subtract? 4x minus 4x is indeed negative 4y minus negative 4y. Because the negative negative would make a plus.
Dang it, I keep forgetting about that.
So negative 4y plus 4y is, well, this looks like the start of the previous problem, or part of what we got on the last problem, yes? Is this a true statement? So this is our infinitely many solutions. Thank you. Now, the textbooks, if you do look up the answers to make sure you got it right, will give you the coordinate, the actual definition or kind of way to define this infinitely many solutions. I'm just wanting you to tell me that it is infinitely many. I don't want you to give me what it is. Because when we talked about it yesterday, how I put up that example with A, had 2A, comma, A plus 4, comma, A, that's the infinitely many solution that we can go to. I'm not wanting us to go that far. I just want us to go to here. And one of the things I will say is if one side, like the last one, instead of getting 0 equals negative 7, if we got one side of the first step up here, in either one of these spots, we got 0 equals 0, go on and do the other side. Because we want to make sure that the other side doesn't give us a false statement. Does that make sense? Because it could be that we get a 0 equals 0 here, which is pretty much saying those two planes are either the same plane, more or less it's saying that they're the same plane. But if I get 0 equals 1 over here, it's saying that those two planes are parallel. So again, we have a false statement. If we get one false statement, it's no solution. Questions on any of this here? I'll remove those last two off there. I would wait to try to copy all that down because it's a lot and it's going to make a little more sense as we go through it. Okay. We're going to do another one. We're going to do some more of these here. And as you've hopefully noticed already, I mean, the last two, one of them was infinitely many, the other was no solutions. But already we can see that the time it's taking us to actually solve this is a lot faster than we did it the first time, yes? Because we took a lot more time the first time to make sure to fully explain it, to make sure you guys understand the steps. Now we're digging into it. So when we look at a problem like this here, which variable do we want to eliminate first? Yeah, I would go y. Because z is fine. We could use z because we have 1z, 1z, and 4z. I could turn either one of the top two into 4z by just multiplying it by 4 and the other one's matched. So that's fine. X, 3x, and x. It's easy to turn one of those 1x's into 3x. But y is 2y, 2y, and 2y. They're already the same. If one of them's already the same, especially across all three, use it. So we're going to do that. Now the next thing I want to do is pick our eliminator equation. Do we want to use the top, middle, or bottom? Bottom. Doesn't matter which one we pick. Now I didn't say this yesterday, I should have said this. The reason I highlighted or mark it is just a reminder to myself, this is the eliminator equation. I'm not going to rewrite it or use it for anything besides eliminating a variable, in this case y, out of the other two. Now at this point here, we can write the other two equations down. Now, since y is already the same, the number in front of y is the same, we can just rewrite it out. We don't have to multiply it by anything to get the y values to be the same. And we can go on with our elimination process. So on the one on the left, are we going to add or subtract? We're going to add. Because we're looking at -2 plus 2. Signs are opposite, so we add, because -2 plus 2 is, indeed, 0. So we're going to add all the way across. X plus -x, 0. Well, this is starting to look like it might be a no solution, but it's not. Because the last variable we have is z plus 4z is equals -11 plus -9. So we would add, we would combine them to get a bigger negative, which is -20. And even with these here, if you struggle with negatives, -11 plus -9, type them in. Let them the calculator do it. Because especially if you second guess yourself on some of them, use the tools you have. So we get 5z equals -20, yes? How many variables do we have there? Solve for it. We would. Divide by 5, telling us z is. This is a nice case. Because if we do an elimination process and get a value, we're 1/3 of the way done. We still need to do this to the other side. So we have 2y and 2y. So what would we need to do? Add or subtract? Subtract, because the signs are the same. Because 2y minus 2y is indeed 0. Let's see what happens to the rest of the variables. 3x minus negative x. The negative and negative would make a plus. So 3x plus x is 4x. Okay. 2y minus 2y is indeed 0. Lastly, z, negative z minus 4z. Negative 5z. Negative 1 minus 4. And lastly, 7 minus negative 9. Negative and negative make a plus, which would indeed give us 16. So I have one equation already solved. I have z equals negative 4. And I have a second equation with two variables, yes? Do I know what one of those two variables is? It's, okay. Now I can just start solving. Negative 5 times negative 4 is going to be plus. Our next step would be to subtract 20, telling us 4x is equal to negative 4. Divide by 4, x is equal to negative 1. Okay. Now what are we missing? Y. All we need to do is find y. So we can pick one of the three equations up here to find y. We can do the first one. We can do any of them. We just have to pick one. So we'll do the first one. So we plug in negative 1 for x minus 2y plus negative 4 for z is equal to negative 11. So I'm going to simplify some of our parentheses. The parentheses around the negative 1 just drop. Our plus negative 4 is just going to be negative 4. So now we get negative 2y minus 5 equals negative 11. Our next step is to add 5 to both sides, telling us negative 2y is equal to negative, and last but not least, we're going to divide by negative 1, 3, negative 4 is our solution, and that is it. Questions on this here? Any questions on anything we've done so far? I think we have, what, one more on the note sheet? 2? How do we feel about these here? Good? Would we like to see another one? Yes? Okay. Out of the last 2, because I want to do want to give you all some time to work on these in class, do we want to look at which one of these 2? We can do this one. This one. So looking at this one here, do we want to eliminate x, y, or z first? Z. Okay. So we have the top one has 1z, the middle one has 4z, and the bottom one has 1z. So we're eliminating z first. Now our eliminator equation can be the top or bottom. Always pick one that's the easiest to make into the other two. Which one do we want to use? Okay. Since we're using the bottom equation, the other two, we can rewrite. And I will state this here, it does not matter which one we put on the left and which one we put on the right. I'm just listing the other two down. Now our eliminator equation for the one on the left, the one there has 1z. Our eliminator equation has 1z. Since they already match, we don't have to do anything to it. I will put in a side note that some textbooks or some ways that this is taught is that we get the sign to be the same also, or make sure the signs are opposite. Some will go that we always need the signs to be the same. That way we subtract every time. Or we make sure the signs are opposite every time, so we add every time. But really, we get the number to be the same and then look at it. If the signs are opposite, we add. If the signs are the same, we subtract. So here, our signs are opposite, so we will add. And simplify with this. Here, x plus 3x is 4x. Y plus 2y is plus 3y. Z plus negative z, 0. And lastly, negative 1 plus 0 is negative 1. Now we're going to look at the other side. What do I need to multiply by our 1z to get it to be 4z? 4. So we can do negative 4 or we can just do 4. Yeah. So the first thing we're going to do is distribute the 4. 4 times 3x is 12x. 4 times 2y is 8y. 4 times z is 4z. And always our favorite multiplication, 4 times 0 or anything times 0 is 0. And once we have this, we can plug it in. So we have 12x plus 8y plus 4z equals 0. Just making sure I have the signs right. Now at this point here, would we add the two equations or subtract them? So negative 4 plus 4, 4 minus 4 is 0, just like we wanted. So we're going to add. 4x plus 12x is 4y plus 8y is, yeah. And negative 2 plus 0 is negative 2. Oh, that's unfortunate. Just the next step, or kind of where we're going. What do we, okay, so are we good to this point so far? Okay. No, I just know what the answer is. Well, it's part of just looking at, I'll explain it here in a minute. Which variable do we want to eliminate next, x or y? It doesn't matter, because either one we can make into the other. So if we do x, well, we're going to turn 4x into 16x. So we can rewrite our 16x plus 12y is equal to negative 2. Now, what do we need to multiply this equation by to get 4x into 16x, or turn it into it? 4. And if we distribute the 4 times 4x is 16x. We have the same number in front of x, yes? 4 times 3y is 12y, and 4 times -1 is -4. We can put it underneath. Questions on this so far? Yep. Now, since both of the x values are positive, 16 and 16, we would subtract because 16 minus 16 would indeed be 0. 12y minus 12y is, so the entire left side is -2 minus -4. Because a negative make a plus. -2 plus 4 is 2. Either way, we get 0 equals 2 or 0 equals 6. Is that a true statement? So this is. But that's why I was kind of saying that's unfortunate, because when I looked at the previous one, to eliminate x, we would multiply it by 4, which would have given us 1612. But the third term, what it was equal to, was not going to actually give us something else. It wasn't going to give us something the same. Because multiplying both by 4, as we saw, we get this. If we did it with 3y, we'd still multiply both of them by 4, which would match up the x's, match up the y's, but what it was equal to would still give us a number. So there's going to be no solution. Questions on this here? I want to give you the rest of the class time to work on these problems here.